Welcome to FOBtv, the future of business. I'm your host, Kevin Benedict. I'm a futurist here at TCS, and I'm excited to have all of you here at the show today. My guest, which I'm really excited to introduce today, is Kamal Sen. Kamal, thanks for joining us.
Thanks so much for having me, Kevin. It's a real pleasure to be with you.
Absolutely. So Kamal is an associate professor at Boston University and a researcher in theoretical and computational neuroscience and auditory neuroscience. So we're going to take a deep dive today and have a lot of fun with this. I think we're going to be combining things like the health of our hearing systems with AI and take a deep dive into that and what that might mean for all of us. So before we get started here, Kamal, where are you calling in from?
So I'm calling from Boston, which is home of the Boston Celtics.
All right. Yes. And they just won the championship. So were you a big super fan and watching that whole series?
Oh, absolutely. Everyone in the city is, just thrilled and excited.
I love it. What is that? The first time in 18 years or something like that?
It's been a while.
A long time. Whatever it was, it's been a long time. So let's go back here to your introduction. A researcher in theoretical and computational neuroscience and auditory neuroscience. How did you end up studying those topics? What was your journey, Kamal?
That's a great question. So, at the undergrad level and as a beginning graduate student, I actually studied physics. So for me, the journey was all about, meeting the right people. So my mentors were amazing, really smart people and really passionate about neuroscience. So, I just basically followed them around and worked with them and tried to learn as much as I could from them, and then ended up in neuroscience and then finally in auditory neuroscience. So it's actually funny because when I talk to my students, they often ask me, is this the right field to go into? Is that the right field to go into? And my answer is that my own journey was about, just finding really smart people to work with, and then you end up in a really good area. So yeah, it's a fascinating field, and I'm happy to be working in auditory neuroscience.
So today, because of that, we're going to end up taking a deep dive into hearing and what we can do about hearing loss and all that. But let me just start out by saying last week, very near our house here within walking distance, my wife and I went to a Jon Batiste concert. So Jon Batiste, he used to be the opening act for Steve Colbert. And he was here and he won a lot of Grammys last year. So he's like rocking and rolling. It was a lot of fun. Anyway, at that concert, my wife kept talking to me and I kept trying to guess what she was asking me. But all my answers were wrong. And she's like, "Are you not hearing me? Why are you guessing and responding to the wrong question?" It's because, boy, when you're in a crowd, in my current seasoned age, I can't hear very good in a crowded room. And so I just started guessing what my wife was asking me, and that didn't go over well. So today you're going to help me be able to deal with that better, I hope, with what you've learned here. So before we do that, though, talk to us about your teaching. What classes do you teach now at Boston University?
Yeah, so I teach computational neuroscience, which is basically making models of the brain, mathematical models of the brain. And I'm in an engineering department, so I also end up teaching foundational math courses in AI. So we've developed some courses like computational linear algebra and then probability and statistics for the data sciences. So it's fun. It's like foundational math courses for AI.
So talk to us about hearing loss. How did you connect, the mathematics, the AI, and developing algorithms and teaching, and you connect that to hearing? How did that journey look?
Yeah, great question. So when I started my research lab, my focus was on understanding how the brain processes natural sounds. Much of the field had studied, fairly simple sounds like tones and noise. And we knew very little at that point about how the brain was representing natural sounds like speech or music. So that led me to this problem of understanding speech in noisy backgrounds, because as you pointed out with your story, we live in a very noisy world. People are talking around us all the time, like at cafes or markets or a noisy workplace or a concert, like your situation, right? So somehow we have to be able to understand and communicate in those settings. So my research, which started on natural sounds, really led into this problem of communicating in noisy backgrounds, which is really my focus now. It's called the cocktail party problem.
Well, that's a very relevant name. That absolutely. So let's start before we start going down deep into this subject. Why do we lose hearing as we age?
So some of it is accompanied by kind of the natural process of aging. It could be degradations in the peripheral mechanisms in the ear, but sometimes it's also central processing mechanisms that can be compromised. So there's a long chain of events that ultimately leads to you being able to hear the sounds going all the way from the ear up to your brain. And so really any deficits all along that pathway can lead to deficits in hearing. One particular part that people struggle with, like, people my age and older, is, hearing in noise becomes substantially more difficult. So people are usually fine in quiet settings, but as soon as you introduce other sounds, it becomes very hard to isolate and segregate those sounds.
So then walk us through what you've learned in these algorithms that you're developing, how they assist in dealing with that challenge.
Yeah, so my lab has studied this problem from a neuroscience standpoint for almost 2 decades. So, we have studied how the brain responds when there are multiple sounds in an environment. And based on that knowledge and a lot of previous work in the field, we essentially created a model of mimicking how the brain processes these sound mixtures. And then from the model, we were able to actually engineer an algorithm that essentially mimics these mechanisms. So it synthesizes known mechanisms in the brain and sort of generates this algorithm for processing sound mixtures. And we call it selective listening. And it basically allows you to focus on a sound, like, for example, the person in front of you, and it basically suppresses surrounding sounds like other people talking or traffic noise or music, and really allows you to focus on the target that you're interested in.
So how do you take this knowledge that you've learned and actually apply it to something that I could buy on the shelf? What would that process look like?
That's a great question. And that's exactly where we are. So we have developed this technology and we have patented it. And now I'm an academic, so I'm actually reaching out to partners in industry to see, if their companies interested in licensing the technology and applying it in their devices. We are also eager and happy to work with companies and partners in industry to get it to applications and where people can actually use it. But for example, it could be very useful in improving the performance of hearing aids. For people that use hearing aids, they often don't work very well in noisy backgrounds. It's a common complaint by hearing aid users. But it could also be used in ear pods to improve listening in noisy environments. Smart glasses, anywhere where you have, sound processing technology, this algorithm could help us pre-process the sound and improve listening in noisy environments. So we are hoping to connect with industry partners and really get to the next stage of applications and off-the-shelf items.
Okay, listeners, if you're sitting on a whole lot of investment capital and you want to do something with this, or you know somebody that's in any of those industries, I need this technology. So I would encourage you to reach out to Kamal and talk to him about these algorithms and things. So walk us through how you would actually do that electronically. So you have these capabilities of recognizing and selecting different sounds and increasing some sounds and focusing in on other sounds. But how would that actually manipulate electronics? Do you have a feel for what that would look like?
Yeah, so we have some prototypes of this. They're actually pretty simple because if you think about it, the brain is just incredible, right? I mean, it just uses the inputs from the 2 years, right? And from that, it is able to do all these amazing things, right? That's all it has access to. So in fact, for the algorithm, all we need are two microphones that's placed at about the location of the 2 years. And from those two microphone inputs, we can process the sounds and recreate a target of interest and suppress the distracting sounds. In contrast, there are other technologies, for example, beamformers are are pretty popular in the field, as well as deep neural networks. Recently, beamformers usually require a large microphone array for them to be effective. So they're pretty large, like 10 to 16 microphones. And DNNs are really powerful, but they are very, very they consume a lot of energy because they have many layers and architecture wise they consume a lot of power. So we think this technology could have a niche in applications where you need sort of a compact form factor. Only two microphones are needed, and energy efficient, power efficient applications. So it could be good for mobile phones, smart glasses, ear pods, things like that, where those are attractive features.
So what makes this different is it's kind of an inside out approach where you've learned from the brain and you see what the brain is doing with sound and you adapt that methodology instead of an outside in where you're just enhancing electronics and then providing the stream. Am I understanding that correctly?
That's absolutely correct. That's a very good point, Kevin, because one of the issues that often comes up in AI, as you know, is that many of these algorithms, while very powerful, are not transparent, meaning that it's very hard to know exactly how the computations are being carried out. And so what's nice here is that because we have this model that's based on the brain, we know exactly how the computations are performed. It's completely transparent. And as we learn more about the brain and how it works and does these amazing things, we can integrate that knowledge into the model and make it even better.
So talking about the energy use, let's go back to that you mentioned a moment ago. So using this strategy with the algorithms based on neuroscience and the way the brain operates, that is a much less power intensive methodology for deriving an understanding of sound than if you did some of the other competitive, just enhancing sounds all with electronics. You're suggesting that takes a lot more energy. Did I understand that right?
Well, yeah, with many artificial intelligence architectures, because of the number of layers and the types of neurons they use in the models, they're typically fairly demanding in terms of energy consumption. Not to mention the training process, which takes a lot of data and a lot of hours of training, and that also consumes a lot of energy.
So I was researching this topic, it must have been like 3-4 years ago. And I found this startup company that was raising funds, it's kind of a kickstart thing. I put some money into it and got a beta version of it. But so it was powerful and it did have a cool mobile app and it allowed you to manually select a lot of different sounds, but it would only last like an hour or two. And I mean, it wouldn't even get you through a cocktail. Well, maybe a cocktail hour, but it wouldn't do 2 hours or 3 hours. And I'm like, that's not the answer when it only works an hour at a time. What do you do with the other 23 hours in the day that you may want to be listening?
Exactly. I would want to stay at the party a bit longer.
Yes, I know. So, I mean, I would appreciate this whole idea about the power consumption. And from a competitive standpoint, boy, so I'm 59 and I'm getting all kinds of advertisements for everything to do with old people. And I get a lot of, hearing aid kinds of stuff being pushed my direction on social media and other kinds of things. So you see this in addition to power, what else does your kind of algorithmic based strategy for this? What other competitive advantages might you be offering?
So power is one. The compact form factor, just needing two microphones is an advantage over other technology. The other thing that's really, I think, very interesting and potentially very powerful is that, the algorithm is essentially based on spatial location. So you basically tell the algorithm where in space you want to attend, right? Is it the person in front? Is it the person off to the side? So there's an element of it that's very spatial. And we naturally do that when we are at a cocktail party. We tend to orient to someone when we look at them.
Yes.
And then we can hear them better. So it's a very natural way of interacting in noisy environments where you orient towards a particular location. The other advantage is that there are very powerful technologies these days for processing images that at a certain location you can recognize faces. And so visual AI can be integrated into this technology as well by combining, all of the features of image recognition and machine learning, which could be connected to the spatial processing as well. So I think the spatial element could be very, very powerful in integrating with other types of technologies that are already out there.
So let's talk about a scenario. So you walk into a room, you've got some smart glasses, also integrated with this technology for hearing, selective hearing at a cocktail hour. So what you're suggesting, if I understand this right, is that you could scan a room and there's a bunch of unfamiliar faces, but then you recognize a face that you have in your memory on your smart glasses. And so it may automatically focus in on recognized faces from an auditory standpoint until you orient it somewhere else. Is that my understanding?
Absolutely. So right now, the simplest way of steering this algorithm would be using some kind of a visual interface like a dial almost or a compass, right?
Wow.
But you could imagine other ways of steering it where it could be steered based on your eye gaze position.
Yeah.
It could be steered based on eye tracking. And in fact, we're actually currently investigating steering it using attention, using brain signals. So,
oh my.
So basically, if you could decode, where the person is attending in space, then you could use that to steer the algorithm.
Oh, that's fascinating.
Yeah, there are a lot of exciting possibilities.
I can imagine, a James Bond scenario. You look through a crowded room and then you gaze at one particular person 50 yards away and it amplifies that voice. That's futuristic. But on that note, let's talk about the future of hearing. Where do you see this hearing technology, even beyond what we just talked about? Where do you see it in 5 to 10 years? How do you think it might change?
So, when I teach my data science AI course, one of the quotes that I often tell my students is this quote, which says, we are drowning in information, but starving for knowledge, right? So, we're living in an age where it's all about data. We are constantly bombarded by these streams of data, but data by itself is not really that useful, right? These strings of numbers, they're coming at us from all angles, right? So I think technologies that allow us to actually navigate that type of a world more easily is going to be increasingly valuable, where we take that input and we process it and we present it to humans in a way that's easier to digest, easier to understand, and then we can make better decisions and navigate this type of complexity. So I think AI has a huge role to play in that. I feel like AI has the potential of making it easier for us to process, digest information, and then make better decisions. And I think this technology is an example of that, where you can focus in on relevant sounds and understand those better, those behaviorally relevant, meaningful sounds more better, and then kind of tune out the noise. So that's extremely helpful for decision making.
This is an example of technology that can directly impact your quality of life. So that's the one thing. Boy, I'm excited to see where your technology goes, Kamal. I am a fan of it already because I can see the relevance in my own life. Thank you so much for joining us today and sharing your knowledge with us.
Absolutely. It was fantastic. Thanks for having me on the show.